We are getting into the applications of the concepts which were previously discussed. I start off with a simple question in the textbook which says that you should determine the angles made by the vectors v is equals to negative 36i plus 15j with the positive x and y axis. Write the unit vector n in the direction of v. As you can see, there are two parts of the question, and for the first part we are going to use something called direction cosines. By direction cosines, what do I mean? If we have a vector v, v makes an angle with the x, y, and z axis in 3D space. Okay, that means if I'm gonna say that I have my x-axis going this way and then my y-axis going this way, okay, and I'm going to ignore the z-axis because this question is about a plane where we are having only two axes. From that I can show you how do we get the direction cosines. Alpha is an angle made with v with the x-axis, and beta is an angle made by v with the y-axis, and gamma is also an angle made by v with the z-axis. Okay, right now let's say we have a vector that is going this way, and if this is vx, this one is vx, and a vector going up is vy. This is the resultant v, okay, which is made by squaring the components. How do we get v? By Pythagoras. Then that means we are going to get the magnitude as vx squared plus vy squared. Okay, and because this is the x-axis, right, I said the vector v, which is this one, this vector going this way, makes an angle with the axis which is called alpha. And if we use trigonometry, cos alpha is going to be equals to what? Vy, vx actually, adjacent, this is the adjacent side, and what is the hypotenuse side, which is the magnitude of v, the resultant vector. Okay, similarly you can show that cos of beta is going to be equals to vy over the magnitude of v, and ultimately we do have cos of gamma being equals to vz over the magnitude of v. And these are our direction cosines. We can use this to get the angles which the questions is asking for. Now we can solve the question when it says we should determine the angle that is made by v with the positive x-axis and y-axis. First things first, we are going to start with getting the magnitude of v. V is given by the square root of what? Vx squared plus vy squared, which is going to be negative 36 squared plus 15 squared. The answer which we get is 39 units. And now what is the angle that is made by v with the x-axis? We get it from the direction cosine. We're going to say cos of alpha is going to be equals to the component, the x component of v, which is given as negative 36. You divide this by the magnitude of v, which is 39. Okay, 36 divided by 39 gives us 12 over 13. The answer is negative 12 over 13 simplified. Right now we get alpha, so we are going to use a cos. It's going to be the angle alpha is going to be equals to cos of minus 1 negative 12 over 13. When you put this into your calculator, you say negative 12 over 13. You get an answer of 157.38 units, degrees actually. And now we move to the y-axis. It's going to be cos of beta is equals to 15 divided by 39. From this we get that beta is going to be equals to cos of minus 1 15 over 39. You get an answer of 67.38 degrees. Now we need to ask ourselves, does this make sense? Okay, then I'm gonna draw my Cartesian plane. Let's say we start from the origin, and then this vector says that we should move to the left. Excuse me. It says that we should move to the left, and then we should move up. Okay, so that means this vector is located this way. And okay, we got the alpha to be 157.38, so it makes sense that this is the positive x-axis, right? We move 157.38 degrees to get to where the vector is. And let's check with the y-axis. The positive y-axis is here, and it says we should move 67.38 degrees. Yes, this angle is less than 90 degrees. That means we are correct. And one important thing to emphasize is that direction cosines are referring to the angles made with the positive axis. It doesn't matter whether it's the positive x, y, or z. Okay. The second part of the question says that we should write the unit vector n in the direction of v. Recall that a unit vector is simply the vector given divided by the magnitude of the same vector. Okay, so right now we call it n. And what is v? It's negative 36, 15. You can also write them in terms of ijk. And then the magnitude is 39. Okay, so I'm going to say negative 36 over 39. I think it was negative 12 over 13, 15 over 39. Now to check what is the magnitude of n, is going to be the square root of 12, negative 12 over 13 squared plus 15 over 39. This should give me a magnitude of 1. And yes, the magnitude is 1. You can confirm with your calculator. We are now moving on to the next question. And now here is the second question, which says that we should determine the magnitude of the vector sum v is equals to v1 plus v2, and the angle theta x, which v makes with the positive x-axis. Complete both graphical and algebraic solution. I am not going to do the graphical solution because you'll simply have to use a ruler and a protractor to do everything by the parallelogram law of combination. The parallelogram of combinations simply says that if you have a parallelogram, let's say you have two vectors drawn tail to tail, okay, here's vector 1 and here's vector 2, it says that if you copy this, all right, and the initial scenario is that we have two vectors, v1 and v2. What is the resultant? By the parallelogram law of combination, it means that you take the v2 and you put it here, okay, and similarly v1 comes here, and then we have formed a parallelogram. From there, the resultant is going to be given by this vector, which is simply v1 plus v2. So this is the vector v is equals to v1 plus v2. That's the parallelogram law of combinations. So the graphical method simply means that if you have a certain scale, maybe a certain scale, and you've measured v1 with your ruler, measured v2, you can use the same ruler to measure the length of v, and then if your 1 centimeter is equals to 10 units, then yeah, let's say this is 5 centimeter, this is 3 centimeter, then you can say that the v is going to be equals to 5 times 2. Then you get your 10 units. That's simply the graphical solution. And now we are going to use the parallelogram law of combination in this exact case. Now, how are we going to start this thing? We are first going to start by obtaining the following angle. So let's say this angle is theta. We are given 4 and 3 as the sides of a triangle. So we have an angle theta here, which is the same as this angle theta. Okay, so it's going to be tan theta is equals to the opposite side, which is 4 over 3. Then from this you can get angle of theta to be tan minus 1 4 over 3. Put that into your calculator, you get a value of 53.13 degrees. Okay, now we do know the value of theta. And now the next step is to draw the resultant vector. To do that, I take v1 to this other side, and similarly I do take v2, same length, same angle. I take it as it is. I take it to this other side. With this being drawn now, what is the resultant? We said that the resultant is the vector that goes to the opposite side. This is v, which is equivalent to v1 plus v2. Now to do this, you can resolve the vectors v1 and v2 into their respective components. From there you can sum the components, say v1x plus v2x. Then you get your y components, you add the y components. That's another way of doing it. However, I will not be demonstrating that method on this example because we are going to use it on the next question. I'm going to simply do a geometry. I'm going to approach it from a geometry perspective. Now, what is v1 plus v2? What is the resultant vector v? Right now, we have formed a certain triangle. And from this triangle, what do we know? We can manage to get this angle here, because to work with triangles you need angles. Now what is v? What is this angle over here? Let me call it beta. What is beta? Okay, if you look, there are many ways you can get the angle using geometry. it's not just limited to what I'm gonna do. What is this angle over here? Okay, let me call it alpha, this one, the blue one. Hope you can see it. What is alpha? Alpha is going to be simply 180 degrees minus theta plus 30 degrees. We do know angles on a straight line sum up to 180 degrees. So 180 minus 53.13 plus 30 degrees. The angle alpha is going to be 180 minus 53.13 plus 30 degrees. You get a value of 96.87. Now from this we can say beta is going to be equals to 180 degrees minus this 96.87. Okay, 180 minus, the answer is 83.13 degrees. This comes from the fact that angles on parallelogram are supplementary. These angles that are opposite or adjacent, I don't know which one is the word, these, they always add up to 180 degrees. Now we can use the law of cosine to find the magnitude V. Therefore V squared is going to be equals to what? The other side squared, which is going to be V1 squared plus V2 squared, and minus 2 times V1 times V2 cos of the angle beta. Okay, so V is going to be equals to the square root of the following expression, V1 squared. V1 is given as what? V1 is given as 27 units squared. And what is V2? Maybe if this might confuse some of you, this part about V2, the V2 is this side, and we took it from here because they are equal, so I just put it that side. So it's going to be V2 squared. What is V2 squared? It's 21 squared minus 2 times 27 times 21 cos of what? Beta, and beta is 83.13 degrees. V is going to be equals to you get an answer of V being equals to 32.16 units. Okay, now they are saying that we should get the angle theta x, which V makes with the positive x-axis. Again, you use geometry. The angle which they are referring to is this angle here, not the 30 degrees, is the angle here. And we already have 30 degrees. To get this whole angle, what we can do is we can first start to focus on this one here, call it angle x, this one here, and from there you are to use your sine rule. I'm going to say that sine x, okay, let me change the color, sine x divided by V2 being equals to what? 21 is equals to another known side. Which one is another known side? It's V2 is known and V is also known. Oh, we've already used V2, so it's going to be, should I use V1? I'm gonna use V because we don't know the following angle. It's going to be sine of beta, and beta was found to be 83.13 divided by the side which is opposite the angle, the magnitude V, which we got to be 32.16. Now what is going to be? X is going to be equals to sine minus 1, and then you are going to write this here. Now let's compute. .41 degrees. Okay, now the angle that is made with the axis theta x, it's made up by x plus 30 degrees, and then we found this to be 40.41 plus 30, which gives us 70.41 degrees. And yeah, that's how you do the question. This question was very popular. It was very popular for last year's group, so, and a lot of people made the mistake of resolving into components unless stated otherwise, and they only got partial marks. So be very careful of that. This is usually the way this is usually what is tested in the first spot test, the parallelogram law of combination.